The renal system is an absolutely fascinating system, and I'm excited to talk to you about it today. As we go through this system, we're going to learn how it integrates with the cardiovascular system to help regulate blood pressure, and how it integrates with the respiratory system to help regulate blood pH. It has a number of different very important roles that it plays physiologically. We know about some of them. If you ask anybody about the kidneys, what do? They're going to tell you that they filter the blood to remove waste. I mean, that's the first thing that most people think of. Equally important, maybe even more important, it's going to help regulate that blood volume by maintaining what I like to call the fluid balance of the body. Fluid balance. To make sure that we're adequately hydrated, and also that we have the blood volume necessary to keep our blood pressure elevated. Electrolytes, super important too. This would help us to maintain and regulate blood osmolarity, and not just osmolarity, but also proper sodium and potassium and even calcium levels are all affected by kidney function. And then, of course, together with the respiratory system, it's going to help to regulate pH, the acidity of the blood, the presence of bicarbonate ion in the blood, the buffering capacity of the blood. You might have forgotten, I'm hoping you didn't, but if you think back to your hematology and erythropoiesis, the production of red blood cells, the process of erythropoiesis is regulated by erythropoietin, and it's the kidneys that release that erythropoietin. So that is also a very important function. And then, in addition to the erythropoietin, which is technically speaking a cytokine, although you could think of it as a hormone, performs a similar role as a hormone, the kidneys also release something that is truly classified as a hormone called calcitrol, which is involved in maintaining homeostasis together with the endocrine system, with the parathyroid hormone released from the parathyroid glands, and the calcitonin, which is released from the thyroid gland. Those are the big functions, and I want to make sure you understand those functions. And as we take a closer look at the kidneys, I hope you can see how these all fit in and why they are so very important. We'll begin with a quick review of kidney structure. This should be old news to you. You've had your anatomy class, you should be comfortable with it. But in case you're a little rusty, we're going to take a look at the kidney in the picture on the right. We'll begin with looking at the renal cortex. That's this outer region right here. I'm going to color it in green so you can see our renal cortex here. Okay. Beautiful renal cortex. And then we have what is known as the renal medulla and the pyramids that are present within the renal medulla. And the pyramids I'll just color here in pink so you can kind of see those and see my beautiful technicolored kidneys here that you can look at here. And then from there we're going to look at the renal pelvis, which is this region right here. And of course, everything empties into the renal pelvis, first going into the minor and the major calyx, which I'll show you. I'll highlight those, and then emptying into the renal pelvis. And then from the renal pelvis, it enters into the ureter, and from the ureter, it's going to go into the bladder, where fluid is stored, and then it is removed from the body through the urethra and exiting out the body in that manner. Zooming in on the renal cortex and the renal medulla, we're going to see the nephrons, which are the functional unit of the kidneys. So these nephrons have, let's actually even zoom in a little bit so you can get a better look here. They have a capsule structure. We're going to look at that and talk more about that. That's the Bowman's capsule, and it closely associates with the capillaries, glomerulus capillaries. You have your proximal and your convoluted tubules, and then eventually you end up in a loop of Henle. My convoluted proximal tubules, and then my distal tubules, and then finally into a collecting tubule. And you're going to notice each of these little branches right here that I'm coloring in red. Those would come from other nephrons. The other nephrons are not drawn because it would complicate the drawing too much and you couldn't see. So this main area here, this is what's going to collect the final product, and then it empties it into the minor calx, which will then go into the major calx, which will then go into the renal pelvis. Okay. If we look a little closer at that nephron here, we can see it in more detail over here, and so you can actually see here, let's lower that, probably that one's good enough, with our Bowman's capsule here, also called the glomerular capsule. Proximal tubule, which I'm going to color in here, it's convoluted, loop of Henle, descending and ascending loops, the convoluted distal tubule, and finally the collecting tubule with each of these branches again. So this branch would be from a different nephron, this is from another nephron, and from another nephron, etc. And so that's the basic structure of the nephron. You're going to want to make sure you know those. We're going to talk about them, refer to them frequently as we talk about the function of the kidneys. Some statistics that I want you to be aware of. Okay. Nephrons. These are our functional unit, and by functional unit, it's the smallest unit that can perform the function of the organ. And so as the function of the organ is to all of these lovely things: reduce or regulate blood volume, remove wastes, regulate blood electrolyte levels, regulate pH. Those are all done by the nephrons. And we have a lot of them. We have approximately 1 million nephron per kidney, so that would make it 2 million since we have 2 kidneys each. As we age, some of those are going to become damaged and closed off and not function as efficiently, and so we'll lose some of that functionality. We usually don't notice any difference. We're not going to see any change in homeostasis until we've lost a whopping 3/4 of those nephrons. At that point, we will start to notice some different. We're going to start to feel not so great, and our electrolyte balances and our blood volume will start to be affected. This is actually why we can donate a kidney, because of course if a healthy individual donates a kidney, they're still working with half the normal number of nephrons, 1 million nephrons, assuming that that is a healthy individual with a healthy kidney.